Hello everyone. So today we're going to cover the fourth part of this chapter. So in one of our previous videos, we've gone through index laws and they sums up into these four laws. So today we're going to use these laws but with negative and fractional indices, and we're going to put these four equalities to our use. Okay, let's get started with example 9. The best way to learn maths is by doing it, so let's do that. So here we've got the first example, which is x to the power of 3 over x to the power of minus 3. One thing to notice that we're going to use this one over here because this is the case of division. I'll write it here. A fraction is the same thing as saying dividing. And from my rule over there, I know that m is 3 and my n is minus 3. So minus 3. I'm simply using the rule. I'm not doing anything new. So x3 plus 3, because minus 3 is plus 3. And I'm going to end up with x to the power of 6. Moving on. So the next one, because it's a product and they have the same base but different powers. So we're going to add up the powers, 3 over 2. So adding it up, so it's going to be 4 over 2, which simplifies to x to the power of 2. Is it clear now? So we're basically just using whatever knowledge is there to be used. So for the third one, so what does it look like? It looks like we have to use this one over here. So yes, we're gonna use it. So the m here is 3 and my n is 2 over 3. Okay, simplifying 3 over 3, it becomes 1, and we end up with x to the power of 2. Okay, so another one over here, which is 2x to the power 1.5 over 4x to the power minus 0.25. So I'll focus on the numbers first. So 2 over 4 is 1 over 2. I'll write it here first, so just you can see where that 1 over 2 comes from. And then for the x is 1.5 minus 0.25. Why? Because here we've got a division, okay? So the powers, it becomes like this, 1.5 minus, it comes from here, and then minus 0.25. Okay, so all it's left to do is to simplify. 2 over 4 is simply 1 over 2, and x 1.5 plus 0.25 translates to 1 over 2, x 1.75. So this one, okay, so this one, which one we're gonna use? First of all, I can see there is a cubic root. So I'm gonna use this one over here, this equality, so I can make it into a fractional power. So 1 over 25, because everything is under this cubic root, 125 x to the power of 6, so they're all gonna be like this. Gonna be rewritten like this. So now we've just changed the form of it. We haven't done anything. So I can see that this one matches the rule over here, which is this one, okay? So the power is gonna be distributed. So my A here is 125 if we were to say which one is A, which one is B, and my B is x to the power of 6. So I'm gonna have 125 over 1 over 3 times x to the power of 6. I'm gonna use brackets because there's another power involved, just so we don't mix everything up. And 125 to the power of 1 over 3. So, I mean, you're allowed calculators in the exam, but you can notice that 125 is 5 to the power of 3. Okay? And it becomes like this. And then using the law over here, okay, when you multiply the powers, you remain with five, because um the because it's a cube and we use a root cube, so it cancels out and you remain with five. And if we use the same rule for the second um one, so it becomes x 6 times 1 over 3. So I'm just writing things in so many details so everyone follows up with whatever I'm doing here. So if we do, again, the same products, we're going to get 5 here. And this one, 6 over 3, which is 6 times 1 over 3, it's 2. So it's going to remain as x squared. So we're going to do the same thing for the last one. So for the last one, we have a fraction. We know this rule which says that if we have, for example, a plus b over c, and then a over c plus b over c, okay? So we can split the fraction. Okay, so here I'm gonna split the fraction into 2, and I'm gonna have 2x squared over x to the power 5 minus x over x to the power 5, yeah? So that's what I've done so far. Now I'm gonna get on to using the second law over here. So 2 minus 5 minus x. X is simply 1. 1 minus 5. Can you see what I've done here? And then we have 2x. So 2 minus 5 is simply minus 3. Minus x. 1 minus 5 is simply minus 4. And this marks the end of example 9. So let's move on and do more of this on example 10, where we will evaluate these expressions over here. So let's get started with the first one. So the first one says 9 to the power of 1 over 2. 1 over 2 is the same thing as saying, so from earlier, we said that if we have something like this, then it's the same thing as saying a1 over m. In the case when m is 2, okay, then you don't write it because that is the square. It's like square. A to the power square is a1 over 2, and you can go up. It's only true for a to the power, for example, 3a1 over 3. But here is needless to write it because this represents the actual 2, if that makes sense. So I have 9 over here. So 9, it's a square of 2. So it becomes 3 because the square root cancels the square of 3. So it becomes 3. And we have for this one, we have 64 then here. Then we know that 64, it's the cube of 4. So it cancels out and it becomes 4. So we did the same thing as the earlier one. For the last one, oh, actually not the last one. It is, how can we write this? So from the earlier slide, it was like if we have a over n, it's n. So whatever is in the denominator, it appears here, as in here, and a to the power of m. Okay. So this becomes a square root and a 49 to the power of 3. So it's the same thing as writing 49 to the power of 3. It can go out. So 49 is 7 square power of 3. So it's 7 to the power of 3. And we can simplify that for it to become 343. The next one is 25 to the power of minus 3 over 2. So we said earlier that if we have like a minus m, then it's 1 over a to the power of m. Okay, so I'm gonna go from here to there. So 1 over, it just changes the sign, 25, 3 over 2. So instead of being negative, it becomes positive, but it becomes in the uh, denominator instead of the numerator. So here I have, I'm gonna rewrite it using this law over here. So it's gonna be 1 over 25 the square root over 3, okay? And it's gonna be 1 over 5 square, because it's a square, the square root cancels out the square and it becomes 5 to the power 3, which is simply 1 over 125. So we're done so far with this example. So we're gonna move on to example 11. Given that y equal 1 over 16x to the power of 2, express each of the following in the form kx to the power of n, where k and n are constant. So I have my value of y is this one over here, but because it has this value, okay, so we're going to make the substitution. So we're going to rewrite y as 1 over 16 x to the power of 2, 1 over 2, because it's an equality. So we're just going to replace it. So now that we've done the replacing, so I'm gonna use one of these index laws on both of these, because the power, they share it, so it gets distributed. So it's 1 over 16 to the power of 1 over 2 and x2, 1 over 2. So this one is simply x, so I'm writing it here. And this one is 1 to the power 1 over 2 is the same. And for the 16, I'm skipping a step here. So 1 over 2 applies on to the numerator and the denominator. Because it's 1, it stays 1, and 16, it becomes 16, 1 over 2. So, okay, so it's the same thing as square root of 16. We know the square root of 16 to be 4, because 16 is 4 squared. So we're going to end up with, let me write it as an extra step here. So it's 1 over 4x, or alternatively x to the x over 4. We have the same, we're going to do the same thing. So we're going to make a substitution with the same term as earlier. So yeah, so we have 4 and 1 over 16 to the power of minus 1. This one is x to the power of minus 1. Okay, so this becomes 4. 1 over 16, because it's to the power of minus 1, so it's the reciprocal, so it becomes 16. Okay, and this one is x using this one over here, you can see. So m times n, we have the same scenario here, so it's 2 times minus 1. Let me write it over here so you can see it. So 4 times 16, which totals to 64, and x to the power of minus 2. And this marks the end of today's lesson. I hope you all enjoyed it, and I shall see you in the next one. Bye!